Hello everyone, my name is Shannon Mistry. I'm an application engineer with Altair. In this short video, we'll look at how to use the model decomposition feature in Feko. With the advancement of technology, we now find extremely mature and sophisticated antenna designs. In order to solve these antennas, huge amount of computational resources are required. Now, when these antennas are then placed on structures, for antenna placement analysis like aircrafts or ships, this further increases the complexity as well as the challenge. In order to tackle this challenge, FICO allows the users to replace the actual antenna geometries with what is known as an equivalence source. Now, these equivalence sources, they behave like actual antennas and yield comparable results. So this approach, it helps in reducing computational requirements overall. This approach is also ideal for situations where the users might not have the CAD geometry of an antenna readily available. In this video tutorial, we'll be looking at how to replace our antenna with the solution coefficient and use it as an equivalent source. So let's understand the modeling steps of how to replace an antenna with an equivalent source. We'll start by creating an antenna model. This could be any generic antenna. We'll then use the model decomposition as a solution request. This is to generate a .solve file or a solution file. .solve file can now be used in other projects to replace the actual antenna. So we'll then go ahead and open a new project and import the solution coefficient data. And then we'll create a solution coefficient equivalence source that will replace the actual antenna to get an understanding about the accuracy. So let's start by opening CAD Feko. We'll go to the component library and select the helical quadrifilar antenna. Let's specify the frequency to 1 GHz and we can change the configurations to a single frequency. Now let's skip to the model decomposition part. So in order to define that, we'll go to the request tab and under solution requests, select model decomposition. The model decomposition will ask us for two options. We'll go with the all structures option and then we'll just save this model and run. So what this will do is it will create a solution file that can be then used in a new project. Now once the solver is run, let's open a new project. So this time we want to replace this antenna with its equivalent source or with the solution file that we just created. In order to do that, let's go to the construct tab. Under the construct tab, under the field current data, you will find the option of importing solution coefficient data. Here you can browse the location of the file. This is going to be a .solve file. So now we have our solution coefficient data in the CAD Feko file. The next step that we want to do is create a source that reads this data file. So let's go to the source load tab and under equivalent sources, we'll select the solution coefficient option. Feko will ask us if we want to change the work plane of this source. We can just keep it as the default 000 coordinates. So now that the source has been created, we can just go ahead and define the frequency, which is 1 GHz, and we'll also request for far fields in order to compare the two models. Let's save it with a different name and run the Feko solver using the solve run tab. After a few seconds, our model has finished running. So we can now launch Post Feko to compare the results. In Post Feko, we can add the two models together in one session to compare them. So here now I have both my models. I can now go to polar plot and plot the far field results. So we are first plotting the far field results of the actual antenna. I'm just changing the independent axis and changing the scale to dB. Let's also plot the far field results of the equivalent source. Since the far field plots are similar, we are not able to see a difference. So we can go to format and change the marker style to see the difference. So now it can be observed that the far field patterns of the actual quadrifilar antenna versus the quadrifilar antenna using model decomposition are in very good correlation with each other. So here we can see a comparison of the 3D far field results of the quadrifilar actual antenna versus the quadrifilar antenna modeled using model decomposition method. And we can observe the close correlation between both the results. Now let's also compare the computational resources that were utilized for simulating both of the results. So to simulate the actual quadrifilar helix antenna at 1 GHz, it took us about 41 seconds and 53 megabytes of memory. On the contrary, to solve the quadrifilar helix antenna at 1 GHz using the model decomposition method, it took Feko only about 9 seconds and 19 megabytes of memory. So you can see by using the model decomposition method, we can reduce the computational resources requirements to a great extent. I hope you found this tutorial informative. For more information, you can visit community.altair.com.